Hello, welcome to SOL G2. Here we're going to look at what happens with parallel lines that are cut by a transversal. As you can see, there are three parts to this SOL, so we'll break it down into three different sections. First, let's look at some general notes. Here's a very traditional picture of two parallel lines that are cut by a transversal. If two parallel lines are cut by a transversal, then check out all the stuff that happens. First of all, we've got to be really good with our vocabulary here. These are the two parallel lines I'm referring to. I'll mark these lines with a set of parallel symbols. That's two triangles that are filled in along the line. Now we have the correct symbolism for lines being parallel. Now that these two lines are parallel, we can look at pairs of angles and what they or how they relate to each other. First, let's look at corresponding angles. Corresponding angles are angles that are in the same location but on a different intersection. Angles such as 1 and 5. Both of these angles are on the top of their parallel line and to the left of the transversal line. Take a look at angles 5 and 1. What do you notice about their size? I notice that angle 5 and angle 1 are both large obtuse angles. If we pulled out our protractor and measured them, we would find out that these corresponding angles are congruent. Angles 1 and 5 are certainly corresponding. And there are three other pairs in this picture. I'm going to pause the video, write up my answers, and let's see if you agree. Here's what I've got. I chose angle 2, which is the acute angle on the top right side of this top hub of angles, being congruent to angle 6, which is to the top right side of the bottom hub of angles. I've also got angle 3 and angle 7 as a congruent pair. Remember, angle 3 and angle 2 are vertical angles, so they're congruent to each other. Angle 7 and angle 6 are vertical angles, so they're congruent to each other. So now all four angles, angle 2, angle 3, angle 6, and angle 7, are all congruent to each other. The same can be said for the obtuse angles in this picture. Angle 1 is vertical to angle 4. Angle 5 is vertical to angle 8. Angle 4 and angle 8 are a corresponding pair of angles. They're both on the bottom right side of their hub of angles. Now every obtuse angle in this picture is congruent. Next, let's think about consecutive interior angles. The word interior means we're looking at all the angles that are in between the parallel lines, which are angles 3, 4, 5, and 6. The word consecutive means that the angles must be on the same side of the transversal. So, angle 3 and 5 are both to the left of the transversal and they're on the inside of the parallel lines. Well, angle 3 is a very acute angle, whereas angle 5 is very obtuse. So we cannot say that those are congruent to one another. Instead, angle 3 and angle 5 are supplementary to each other. Therefore, all consecutive interior angles are supplementary when lines are parallel. That means I can say that the measure of angle 3 plus the measure of angle 5 would add up to 180 degrees. There's another set of consecutive interior angles in this picture on the right side of the transversal. That is angle 4 and angle 6. Angle 4 is obtuse, angle 6 is acute. They're both on the inside of the parallel lines to the right of the transversal. These are a consecutive interior pair. That means the measure of angle 4 plus the measure of angle 6 sums to 180 degrees. Our next set of angles to discover are the alternate interior angles. Again, we're working with interior angles, which means we're looking at angles 3, 4, 5, and 6. The word alternate means to be on the opposite side of the transversal. Let's use angle 3. Angle 3 is on the left side of the transversal, so the angle on the opposite side of the transversal could be angle 4 or angle 6. However, angle 4 already has a special relationship with angle 3. Angle 4 and angle 3 are considered a linear pair. In fact, they don't even need the second set of angles down here to have a relationship. To use the second set of angles and to also be alternating interior angles, we would want to use angle 6. Notice that angle 3 and angle 6 are both acute angles. If we were to measure them, we would find that they are congruent. Therefore, all our alternate interior angles are congruent. So, angle 3 would be congruent with angle 6. There's one other set of alternate interior angles in this picture. It's the obtuse pair. Angle 4 is on the inside of the parallel lines, and it's also on the right side of the transversal. Angle 5 is on the inside of the parallel lines, and it's on the left side of the transversal. This is an alternate interior pair. They're both obtuse angles, and they are congruent to one another. Our last set of angles to explore are the alternate exterior angle pairs. Exterior tells us that we're looking for angles on the outside of the parallel lines. Angle 1, angle 2, angle 7, and angle 8 are on the exterior of the set of parallel lines. The word alternate means the same thing as it did with alternate interior angles. This means the opposite side of the transversal. Let's begin with angle 1. Angle 1 is on the left side of the transversal and outside of the set of parallel lines. So I need an alternate angle, which means it needs to be an angle on the right side of the parallel line. Well, we have two options here. We have angle 2 and we have angle 8. Again, angle 2 already has a special pair name with angle 1. We don't need the second set of angles down here to compare angle 1 and angle 2. They are a linear pair. Therefore, we're going to want to choose angle 8 as angle 1's alternate interior pair. Angle 1 and angle 8 are both obtuse angles. They're on the outside of the parallel lines. They're on alternating sides. And they are congruent to each other. Another congruent pair. Angle 1 is congruent to angle 8. The other alternate exterior angle pair would be angle 2, which is on the right side of the transversal, and angle 7 on the left side of the transversal. Both of these angles are acute, and they are congruent to each other. Well, my husband and children got home, so that's going to be the end of this video. To wrap it up, try to keep things simple. If there are two acute angles, they are equal to each other. If you're comparing two obtuse angles, they are also equal to each other. And if you're comparing one acute and one obtuse angle, they will have a sum of 180 degrees. Happy studying!